You have a free afternoon, a project you genuinely care about, and zero distractions. So why are you suddenly reorganizing your spice rack? You sit down at a clean wooden desk with a fresh digital document wide open. Within 30 seconds, you feel a sudden, overwhelming physical impulse to check your email, wipe down the counter, or organize trivial files. For decades, we have been told that this frustrating behavior is a personal flaw. We call it laziness, poor discipline, or bad time management. We carry a quiet, devastating cycle of hidden shame, feeling completely broken. Yet you are not procrastinating on a boring chore or an unwanted errand. You are procrastinating on something you actually care deeply about achieving. Why does your brain sabotage the very goals you claim to want most? To understand this strange contradiction, we have to look inside your skull. Your brain weighs roughly 3 pounds and consumes 20% of your body's energy. Remarkably, this massive energy burn barely changes whether you are solving complex math or staring blankly at a wall. Daydreaming burns almost as much fuel as solving intricate scientific equations. For a long time, neuroscientists assumed the resting brain was simply powered down. That assumption turned out to be completely wrong. In 2001, neurologist Marcus Raichle made a discovery almost by accident. While reviewing baseline control scans from PET and fMRI research at Washington University, Raichle noticed a peculiar pattern. Whenever test subjects were explicitly told to lie still and do nothing, a specific network of brain regions lit up like a Christmas tree. Raichle and his team published a landmark paper in PNAS detailing this phenomenon. This hidden neural system was named the Default Mode Network, or DMN. The Default Mode Network is your brain's internal narrative engine. It triggers when you daydream, replay awkward social interactions from 5 years ago, or imagine future scenarios. It is responsible for your sense of self, your long-term memories, and your internal inner monologue. When you are not actively engaged in an external task, the DMN automatically takes control of the driver's seat. To get things done, your brain relies on an entirely different neural system. This second system is known as the Task Positive Network, or TPN. The Task Positive Network handles executive control, logical problem solving, and outward focus. When you write code, build a budget, or focus on a conversation, your TPN is fully active. Functional magnetic resonance imaging demonstrates an anti-correlated relationship between these two systems. They function like a biological seesaw inside your mind. When the Task Positive Network turns on, the Default Mode Network is actively suppressed. When the Task Positive Network disengages, the Default Mode Network immediately floods back into control. While they are often presented as binary switches for simplicity, real-time brain operation involves complex dynamic network interactions. However, for most daily tasks, you cannot run both systems at maximum intensity simultaneously. This creates an unavoidable neural tug-of-war every single day. When you sit down to work on a meaningful goal, a violent state collision occurs. Your default mode network does not want to give up control. It prefers the effortless, low-friction state of internal wandering and daydreaming. To make matters worse, deep personal projects carry immense emotional weight. Procrastinating on projects you are passionate about produces far more acute anxiety than dull tasks. Your personal stakes make the perceived threat of failure significantly higher to your brain. Psychological research led by Dr. Tim Peichel and Dr. Fusha Siwa reveals a surprising truth about procrastination. Procrastination is not a failure of time management or willpower. It is an involuntary strategy for short-term emotional mood repair. When a high-stakes goal triggers internal pressure or self-doubt, your brain perceives that task as a physical threat. The threat response center in your brain, known as the amygdala, immediately sounds the alarm. The amygdala releases stress hormones like cortisol and norepinephrine into your bloodstream. These stress hormones temporarily impair prefrontal cortex function, crippling your executive control. Your brain naturally seeks immediate relief from this terrifying psychological discomfort. Avoiding the difficult project lowers your acute anxiety instantly. Your brain rewards this sudden relief, reinforcing the impulse to clean your desk or open social media. You are not being lazy. your brain is undergoing a biological defense response against self-doubt. Attempting to force focus through sheer willpower often backfires completely. Gritting your teeth increases internal stress, which further overactivates the amygdala. This overactivation locks your brain deeper into self-referential daydreaming and resistance. The secret to breaking this cycle is not force, but friction reduction. You need a reliable mechanism to transition your brain out of the default mode network. We can call this mechanism the 100-second friction bridge. It takes approximately 100 seconds of low-friction engagement to shift control from the DMN to the task-positive network. Your prefrontal cortex needs a gentle entry point rather than a high-pressure demand. Start by shrinking the target task down until it feels laughably easy to perform. If you need to write a book, do not tell your brain to write a full chapter. Tell your brain to open a blank document and write one single sentence. If you need to work out, do not commit to an intense hour-long session. Simply put on your running shoes and step outside your front door. By making the initial step tiny, you bypass the amygdala's threat detection entirely. No alarm bells ring because the task requires almost zero emotional vulnerability. As you spend those first 100 seconds engaging with the physical task, your task-positive network awakens, the micro-transition begins, and the default mode network starts to quiet down naturally. Once the task-positive network takes over, momentum carries you forward effortlessly. The hardest part was never the actual work itself. The hardest part was navigating the neural collision between resting daydreaming and active execution. In our modern world, this biological struggle is harder than ever before. Smartphones and algorithmic feeds exploit the default mode network constantly. They offer effortless, passive stimulation that keeps you stranded in cognitive limbo. You sit in a state of passive consumption, never fully resting and never fully focused. Understanding your brain's architecture gives you the power to break free from this trap. Forgive yourself for the times you defaulted to reorganizing the spice rack. Recognize that your brain was simply trying to protect you from psychological threat and anxiety. You are not broken, lazy, or lacking discipline. You are simply caught in an invisible biological defense response. The next time you feel that sudden physical urge to escape a meaningful project, stop. Take a breath and acknowledge the neural tug-of-war taking place inside your skull. Do not fight the anxiety with forceful willpower. Instead, build a tiny 100-second bridge to help your task-positive network take the wheel. Give your prefrontal cortex the tiny entry point it needs to quiet the noise. You have the tools, the awareness, and the capacity to direct your own focus.
You sit down at a clean wooden desk with a fresh digital document wide open. You take one small, effortless step forward. And finally, your mind steps out of the shadow and gets to work.